Good morning and welcome everyone. My name is Pete Will and I'm Esri's Principal Account Manager to the mining industry. I'm speaking to you today from my office in Broomfield, Colorado, and it's my pleasure to welcome you to this 5th webinar in a series of webinars organized in concert with the Esri Mining User Group. This webinar is entitled Streamlining Image Management and Processing Workflows with Web Services. During the webinar, Peter Becker, Esri's Senior Product Manager for Imagery, will demonstrate how the ArcGIS platform helps you tackle the image management challenges you face in the mining industry, whether they be satellite, aerial, or drone-based. This webinar is being recorded, and a link to the recording will be posted in the next few days. And as a participant, you will receive an email to that link. As is traditional in our webinars, we encourage you to submit your questions throughout the presentation in the GoToMeeting question dialog box, and we'll answer as many of those questions as time permits. Any questions that we don't get to will be answered in a follow-up email. I will be your MC for the webinar, and to start, I'd like to introduce my guests that will be joining us today. First, as I mentioned earlier, I'm joined by my colleague, Peter Becker. Peter is a Senior Product Manager for Imagery at Esri and is speaking to us today from his office in Redlands, California. I'm also joined today by Chris Franks. Chris is with Freeport-McMoRan, and he's in his office in Phoenix, Arizona. So before we get started, I have asked Chris, who is a Principal Committee member for our Esri Mining User Group, to say a few words as an introduction to what the group is all about. Chris?
Good morning, Pete. Thank you very much for the introduction. A quick overview of the Esri Mining User Group. We are a group that is formed and exists to benefit our user community. So we are here to meet the business needs from the mining community and to work with Esri to drive technology to match our business needs for our members. We have been in existence for about 7 years. We communicate through our LinkedIn site, which you can see on your screen. And again, our goal is to drive business value through these webinars. And we are trying to host one of these webinars about every 3 months, 2 to 3 months. And once completed, the webinars will be added to an online library of resources that will be available for everyone. We're very excited about this webinar in particular with the streamlining of image management and processing workflows, and look forward to hearing the great content from Peter. With that, I'll turn it back over to Pete.
All right, great. Thank you, Chris. The material we will be covering today was born out of conversations with the MUG members about how to effectively manage the large amounts of imagery being collected and used in their daily workflows. These use cases and workflows represent real-world examples and have been provided to us by our MUG members and your industry peers. With that, I'm going to turn it over to Peter Becker, and we can get started. Peter?
Thanks very much. Okay, as you know, my name is Peter Becker. It's been great the last couple of weeks actually having discussions with a number of the peers in the mining industry, talking about the issues that they have, getting some sample data. Just a little bit about my background. I used to actually work for a mapping company for many years. I spent about 15 years working for a mapping company. So a lot of the data that I was creating was actually data for a mining industry, road industry. So a lot of my experience comes from actually providing the data and actually seeing a lot of the work being done. So the agenda today is really to try and understand and talk about and to give examples of how we can actually work with large collections of orthophotos and elevation data. I'm going to be talking a little bit about the problems so you understand what the problem is, the solution, talk a little bit about the requirements in terms of software that needs to solve it, and then actually go through specific recommendations on how to optimize and structure your data and create what we refer to as mosaic data sets, which are the essence of how we actually manage and publish the data, and then also show you how to actually create simple apps to actually consume this services once they've finished. Then go for a summary, and as Pete was mentioning, hopefully we'll have some time for Q&A at the end. Just for clarification, what's not going to be covered in this particular webinar is actually the processing of drone imagery and sensors. We have two products, Drone to Map, as well as the orthomapping capability within ArcGIS Pro Advanced that are specifically designed to handle the processing of drone imagery, so we're not going to cover that. We're also not going to go into a lot of details about feature extraction or classification, although a key thing is that the tools that we're using here to prepare the data for consumption by web applications is the same work that's really needed to ensure the data is prepared for usage in these feature extraction classification workflows, and a number of those actually exist within ArcGIS Desktop. Also, as a little bit of a plug, at the end of the year, we'll be actually coming out with the Image Analyst extension, and that's going to be adding some new capabilities to ArcGIS Pro, specifically for things like displaying data in stereo, which might be of interest to this user group. So, as a quick background, from a platform perspective, you've probably seen this slide as we talked about it as the complete platform. Imagery is really an integral part of that, and we see it in the three different systems. One is the system of record, which is what we're going to be focusing on today, is how do we actually manage the imagery that's available and make that accessible to everybody. The second aspect is the system of insight, which is really extraction of information from that imagery. And the third system is the system of engagement, which is really the tools and user interfaces which enable you to consume the imagery and in various applications, both in desktop, web, and mobile applications, and also handles content management. Another important component of the system is actually the content. So ArcGIS has a lot of content. I'm sure many of you are already using things like ArcGIS Online. We also have partners that provide content that you can connect to. And a lot of the content, especially in the mining industry, will actually come from within your organization. So again, today is going to be focusing on how do we actually get the content in your organization accessible to everybody. So let's look at what the problem is. When I talk to a lot of people, the problem is they have discs, or you have discs full of optical imagery, lots of imagery from different sources. Some of it's aerial, some of it's satellite, some of it comes in drones. There are a lot of different formats: TIFF, JPEG, Mr. SID, JPEG 2000. That's a smorgasbord of different data that's out there. There's also a lot of elevation data, and that elevation data is coming as gridded data, things like TIFF files or grid files, but you also have a lot of elevation data in non-gridded data, things like LAS files or point clouds, DGN files, DWG files, point files, and those also need to become accessible. So those problems are confounded by a number of different things. Within the mining industry, the big challenges that you have is that the data is actually spread over multiple locations. It's not like a state mapping organization which is sort of making a single map of the whole state. What's the problem is that we have a lot of different locations. Also, there are it's temporal data, so we have data in different times. Also, it's all in different datums. So some of them are in NAD 27, NAD 28, different state planes, UTM, lots of different projections and datums being involved. Also different formats, as I mentioned, TIFF, JPEG, different resolutions, high resolution imagery, low resolution imagery, different bands. Some of the data is multispectral, some of it's just RGB. And then we also have the different modalities. You have imagery or optical imagery data, you have elevation data, and very often you may have the results of analysis. So these are all things that confound the problem of how do we actually manage all this different data. And this is in many cases very different to other organizations which are typically wanting to create a single background. So what's the requirement? Well, the requirement is to access any image, any point in time, at any location. And this is really needed from lots of users within the organization, some of them connected directly in the main office on a high bandwidth network, other ones with limited bandwidth network. What you're looking for is a single endpoint. The importance of that is it makes the applications simpler to maintain. If you have either ArcGIS Desktop open and you zoom to a particular location, you want to see the imagery of that location without having to go and search for it. Similar in a web application, you don't want to update the web application every time you have a new date. You need fast access, And you need access by all users, but also controlled access. In other words, you need to have security to ensure that only certain users use different data. You want to see it in multiple applications, desktop, web, mobile, as well as third-party applications. Very often those applications can connect to things like OGC, WMS, but also very often want to actually extract data as files. You want to do simple analysis, things like change detection, volume determination, and also moving forward are interested in things like classification. So we have a lot of things to cover here, but what you'll hopefully see is that ArcGIS actually provides the solution for each one of those. So what I wanted to do first is actually give a quick demo. So here's a simple web application that I've created, and what we're going to actually do is in this webinar is actually create the data sets and web applications so you can see how it all fits together. So here I have a simple layer selector, and I can say I'm interested in what I call all NC, which is all my natural color imagery, and you can see I basically have access to this mine site, and if I actually turn on this image selector, I can actually quickly go back and forwards through time. So go to any particular location and very literally instantaneously see what that area looked like at different points in time. Remember, this is just directly in a web browser. So we can look at the image data. If we look at one of these images, let's say this one, maybe it's a bit dark, we want to enhance it. What we can do is just go into the renderer and say I want to have a stretch. I'm going to actually, let's have a look at the different stretch parameters. I'm going to set it to, for example, standard deviation with DRA, go apply, and the server is now enhancing the imagery, so it makes it easier to start seeing in, let's say, areas of shadow, things like that. The imagery gets enhanced, so we can actually start doing simple enhancement of the imagery. So that's, now what about other types of data? Well, let's say we want to have elevation data. I can do the same thing, turn on the elevation data, and here we're actually seeing a hill shade of the data. But what I can do similarly is turn on the same tool and actually see how this area has actually changed over time by looking at the hill shade of the data. Alternatively, I can change the renderer and say, well, actually, I'm interested in, let's say, seeing a slope map of this area, and I'll get a slope map of the area. And every time I actually make a request, it's actually the server that's actually performing the processing and returning this data. So you can then start building more and more applications on top of this data. And also, if we have different dates. So if we, let's say, take this date as, actually change my, let's go back to my natural color. If we select two different dates, let's take, for example, this date as one image, this date as another image, and then we can basically do some comparison. For example, swipe as comparison. So this is one location, but what if I'm interested in another area? So what I can do is say, go to my site. I'm going to go to site 2, and automatically I come to another location, and here's my elevation data again, and let me actually change the renderer back to grayscale hill shade. So here's another location, and again, if I actually turn on the time, I can actually see that there are actually two different data sets. The second data set in this area is actually derived from LiDAR, very high resolution LiDAR data that I can also see. If we go to another location, let's go site 3. Let's go back to, in this area, I only have natural color imagery. So here, another site, and similar, we can actually look at this imagery at multiple different dates very quickly. So what we've been showing is a very simple application that allows me to pan and zoom around and immediately find the appropriate imagery at the appropriate date. So that's also what we're trying to achieve. So what do you actually need to achieve this? Well, For the image management aspect, you need ArcGIS Desktop. What I recommend is using ArcGIS Pro, and the demos that I'm going to be doing are actually all being based on ArcGIS Pro 2.0. But you can also use ArcGIS, ArcMap rather. So ArcMaps also can be used. All the capabilities that I'm showing you can also be done in ArcMap, although I would recommend you start moving to using Pro. The interface is much better. Also, for the actual serving of the data, you will need either ArcGIS 10.4 or ArcGIS 10.5. So at 10.4, the architecture changed a little bit, or at 10.5 it changed a little bit. At ArcGIS 10.4, what you had was really ArcGIS server, and we had the image extension. So you would basically serve your imagery through the image extension, and then could either register it with the portal or with ArcGIS Online. At 10.5, it actually changed to ArcGIS Enterprise, and the server has moved from an extension actually to its separate server, or rather a separate role within the ArcGIS Enterprise. And ArcGIS Enterprise actually has a portal, or has a main portal, and then you connect to that portal multiple different servers. For example, a GIS server to focus on more of the typical GIS work. You have an image server, which is what we're going to be focusing on today. And then you also have GeoEvents, GeoAnalytics server, business analyst server. There are multiple servers that you can actually connect and use within the ArcGIS Enterprise. ArcGIS Enterprise also brings together in new concepts such as data stores, which are basically ways of storing your data in a very efficient manner. From the image server perspective, ArcGIS 10.5 also brings a new capability called raster analytics. We won't be covering it in this presentation, but the ArcGIS image server has two capabilities: the dynamic image services, which is what I was showing you, panning, zooming around, and it renders and processes the imagery and returns it to you. And at 10.5, raster analytics is the ability to persist very large data sets by using multi processors and multiple machines to speed up the processing, and that can be used to do analytics at scale. So, from an infrastructure perspective, what's required? You can either run all what I'm showing either on-premise, and many of you in the mining industry currently are utilizing on-premise solutions. So ArcGIS server runs great on-premise. It also runs very well in the cloud, and we have actually implementations both in Amazon, AWS, and in Microsoft Azure. And for those environments, we actually provide cloud formation templates and cloud builders, which allow you to actually set up ArcGIS Enterprise very, very quickly in cloud environments. So the workflows for actually working in the cloud are actually very similar to working in an enterprise environment. Now, what I'm going to be showing is really much initially how to do things mainly on a desktop, whether that desktop is running on your local desktop, whether it's a desktop remote desktop into a server or remote desktop into a cloud. Typically, you use the desktop to do the data management, and then you can actually scale the system up either on-premise or in the cloud. So I'll talk a little bit about the cloud as well, and some of the slight differences a bit later as well. So, as an engineer, I like basically taking the problem and breaking it into three different parts. What is the input? What is the process? And what is the output that we're going to get from it? So, briefly, the input really is these bunch of files in multiple directories, probably very often spread over multiple machines. The process, what we need to do is find out what we have. That's the first aspect. Many organizations just know that they have data and don't actually know what's in the data. Optionally, it can be you may need to clean it up or optimize it. What you then do is to create the mosaic data sets, which are used to manage the data, and then you actually serve those as image services. So these then can be created as the set of web applications that your users consume. So that's really the process that we're going to go through, and the output of this is going to be a maintainable and accessible set of image services within applications that can be easily consumed by your users. So that's what we're going to go through. So the input, as I mentioned before, what is it? It's a bunch of files, very often different formats, projections, pixel sizes. Importantly, typically you have metadata, and the metadata, especially in the mining industry, is extremely important. In many cases, it's only the date, as well as things like projection information, but it's critical that that is actually maintained. The other question is the data optimized for serving? And I'll be going a little bit more into this, is what do we mean by optimized imagery? Imagery can be there, and it can be very fast to access, and it can be slow to access, and that depends a little bit about the optimization of the data structure. The next thing is, how is it stored, on what drive? And the drive on which the data is stored has actually a big influence on it. You certainly want to ensure that the storage is connected close to the server. I have had organizations, my image server is very slow, and when I investigated it, I find out that literally the storage system is on the other end of the country, and they wonder why it's slow. So you really need the storage and the servers to be close together. And the storage system can have quite a significant effect on performance. So, as I mentioned, it's sometimes advantageous to actually optimize the imagery. The other thing to do is to understand what are the file structures of the data. And typically you will find two, and I'll be referring to two ways of the data that is structured. In some of them, especially in the mining industry, you may have one raster per project. It's quite likely that the organizations that have delivered you the data have actually already mosaiced the data into a single image that covers that whole site. That's typically the case for smaller mine areas, but for larger mine areas, what you may often have is multiple rasters that actually, or map rasters or images that actually cover a project. So it may be an area may be covered by a large number of individual tiles, which really are just because somebody wanted to tile it up into smaller files. It could have been one big file, but it's there as lots of small files. So I'm going to be looking into both of those, and what I'm going to use is the word project. And this project can mean different things to different people. In this case, when I refer to a project, I'm really talking about a single collection of imagery for one date, for a specific site and a specific modality. So a project may be all the imagery covering a particular site flown on a particular date. That's what I'm going to be referring to as a project. So what does optimize mean? From my perspective, it means it's good for fast access, serving, and analysis. What we need to do, and if we want to optimize the data, is to ensure that the metadata is important, is not lost, and is maintained. Obviously, the date is typically the most important part of the data that needs to be maintained. The other things is what's needed as a file format. So for the imagery to be accessed quickly, there are a number of things that need to be considered. One is whether the data is tiled. And by tiled, I don't mean that the large image is cut up into a large number of different files. It's internally to the file, whether it's tiled internally. And there are some formats which are tiled and some formats which are not tiled. So tiled formats are faster. Whether data is compressed. Compression can have a number of advantages. It can speed up access to the data because less data gets transmitted, but you have to be careful that you don't go overboard. If you compress the data too much, you will start losing data, and sometimes some compressions actually slow things down because there's a lot of CPU required in the compression and decompression of the data. So don't go overboard on the compression. The next thing is to ensure there are pyramids. Pyramids are really reduced resolution data sets of the same image, and these ensure that you actually have fast access to the imagery at small scale. So when you zoom out, I don't want to necessarily read the high resolution data. You want to have a format which is standard. Obviously, this is imagery that you want to keep for many, many years. So you need to make sure it's a standard format. And then you have to consider whether it's cloud optimized. And for that, I mean, is it something that you want to actually store in cloud infrastructure in the future? Because the cloud actually does have slight different requirements on the data structure. These things about tiling and pyramids are much more important in the cloud, because access to cloud storage is actually typically rather slow in comparison to a fast disk. So when you optimize, there are a number of things that you need to be very careful of. One is the projection. Don't change the projection or the resolution of the data. That will typically reduce the quality of the data. It's okay, ArcGIS will handle data in lots of different projections and different resolutions. It's not necessary to project when you work on it. Take care in compression. Maintain all the metadata. Don't lose the metadata, and typically don't change the names of any files. What you'll see is that a lot of systems are already linked to those files, or metadata is actually stored as part of those files, so don't change the file names. And then if you are going to optimize the data, make sure you back up the source, obviously. So let's talk a little bit about the formats. There are a number of formats. Some are better and some are worse. So formats which are actually good for serving are things like GeoTIFF, if it's structured well. So GeoTIFF is actually there are lots of different flavors of GeoTIFF, but if the GeoTIFF is what we refer to as tiled with pyramids, it's actually good. There's a new version of GeoTIFF that's coming, or people are talking about, called COG, or Cloud Optimized GeoTIFF. It's really just a standardized. They're trying to standardize it as a way of actually structuring the GeoTIFF to make it faster to access. It's really just tiled with pyramids, but that's good. There's a format called MRF that Esri uses quite a lot, which is a simple format, also cloud optimized. And then we have things like tile cache. Tile cache is not going to be used so much in this case. It's really used for basically large extent-based maps. So those are actually very optimum formats. There are formats which are okay. These are not optimum, but you may not want to convert them. JPEG files, if they're small, for example, pictures of sideways looking images of taken with a camera, they're fine. JPEG 2000 files, they can be okay, but they can be slow to access. So JPEG 2000 is one of those, sometimes good, sometimes not so good. IMG format, typically it's okay. It depends a little bit on the structure internally, but it's generally okay. Mr. SID is typically okay, and there are certain formats that are not so common in the mining industry, things like GRIB and BAG, which may need to be kept in their original format because they have special capabilities, things like golden points. It's not just raster, there are other components inside the images. The formats that are problematic are actually things like JPEG. JPEG itself is okay. It's just when the images become large. If you have a large mosaic and you create a very large JPEG file with more than sort of 5,000 rows or columns, then things start to slow up because JPEG is actually not tiled. There's the grid format. It's an old format by Esri that's actually not good for serving. Things like ASCII grids are very slow. ECW as a format, typically you actually need a special license to serve that. There are a number of restrictions on serving ECW. Then there's things like float and raw. So the last ones are formats that you can use, and we can certainly use them, but they typically are problematic, and it may be better to actually optimize those. So in compression, really have to try and find a balance between how much you actually compress the data, the performance increase or decrease, and the accessibility to the data. So what I typically recommend is for the data that's view only, in other words, you're just going to view the imagery, convert it to, or typically which is 8-bit RGB or panchromatic imagery. What I would typically use is as a compression JPEG with Q85. The format is something typically like TIFF or MRF, but the actual compression method used JPEG. There's a type flavor of JPEG called YCRCB, which is actually more optimum. For analytical data, what I'd recommend is, and that's the data which is typically 16-bit or 4-band that you want to use for analysis, either use lossless, things like LDW, or there's actually, MRF has a format compression called LURC, which is a controlled lossy. It's actually very, very fast way of compressing data and controlling the actual compression that's used. That would also be used for things like floating point data. Also consider that some organizations take the analytical data and actually create an 8-bit or 12-bit version with JPEG just to get the size smaller. So you really have a decision point now as what you actually do. Do you use your existing data and optimize the specific files where possible? And yeah, you might want to do that, especially if you've already maintained the data well and you've been working on the data for a long time, and you know all your data structures, and you've been making sure the data is well structured. You may want to do that. And then what you want to do is to just go through those files and check if they can be further optimized. For example, adding pyramids. Typically, you may have a large JPEG file and it doesn't have a pyramid. You can just basically run create those pyramids for those files. The other alternative is to actually create an optimized version, and this is typically used for organizations if you have disks lying all over the place and the data is spread and it has not really been managed. It's a real mess. Then it's actually better to actually go through those disks and optimize them and create a new data structure which contains all the data that you've actually maintained and ensure that the data is actually being cleaned up. So in that case, you actually create a new copy of the data, but you also have the opportunity to refine and optimize the formats. So in some cases, that's also applicable. So what's the easiest way to actually look through your data? And this has always been a challenge, and people have always said, oh, there are some really good tools for finding all my imagery and stuff like that. All the tools that I found, the best one is actually just to go to the command line and type the command that you see there, basically create a directory of the listing. It'll just create a list of all the directories and then open that file and go to each directory and have a look what's inside each one of those directories. Typically, you will find the images, but then you will also find a lot of other metadata and things like that that will not be typically picked up in crawlers. And that's why it's really very often necessary to actually go through and then just document what is in each one of those directories and record what is the metadata, typically what is the format, what is the projection, is the data georeferenced, are there additional metadata files, are there junk files? Unfortunately, crawlers and stuff will not pick that stuff up. So you really need to quickly go through it in a file explorer and or in a catalog and check what the data is. That's just a job that just has to be done at some point in time. To clean it up, there are various things that you want to do. One is if you're going to leave the data in place, is to use ArcGIS build pyramids and statistics tool. That can be run very quickly, and it will just generate the pyramids. Pyramids are important to create for the data. Don't worry about statistics. Statistics are not very often used. Typically, if I run it at all, I will use it with a large skip factor just to make it run faster. If you do sampling, create the pyramids, do use the bilinear sampling. It gives a better quality. Check the no data. And what you'll see is that increases the data volumes by about 30%. The other one is to actually create the optimized reference data. Very often, it's better just to actually get a separate disk and then create and maintain a data structure, something that actually makes sense. Typically, country, site, year, project, images, country, site, year, project, elevation data. Create a sensible directory structure. Use a standardized naming convention. The date is always the challenge, especially in America, where you put the month first and then the day, and then you never know whether 6/4/2005 was April or June. So it's better to try and standardize the naming convention. Typically, I use year, month, day. It's clear what it is. Don't rename the files, and try not to have directories, have rasters in subdirectories of directories with rasters. In other words, don't have a bunch of images and then have a subdirectory in that which has got more imagery in it. That actually makes things harder to maintain. Also, look at the metadata. There is no good metadata standard. Many organizations have their own way of maintaining it. Very often it's just by maintaining the file names or directory names. Also consider there is actually within ArcGIS used by something called GDAL, something called an AUX.XML that can be used to store metadata. And if the data is in that AUX.XML file, ArcGIS can automatically extract that information into the Mosaic datasets. So you got these large collections of imagery. How do you actually optimize it? One of the tools that we provide is something called OptimizeRasters. It's basically a simple GP tool. I'm just actually going to very quickly show that. I'm just going to, it's actually in the GitHub site. You can go to into the setup directory and literally just download it. It'll download onto your computer. It's very fast. You can then just run it. I'm just going to put it into this directory. So it's basically installing it. So that's literally how fast it is to install. And if I then go to ArcGIS Pro, what we can do is to go to your toolboxes, go new Python toolbox, and we can actually find where the data is. It went into C, image workflows, OptimizeRasters. And there's my OptimizeRasters tile. And do you want to override existing files? Yes. And now we basically have OptimizeRasters, and I must hold on. I installed it before. I need to actually do that again. Sorry, I was doing the wrong one. OptimizeRasters. And sorry. See. Okay, I messed that up. Why does that not work? Toolbox is add toolbox. I think I had it already installed. I shouldn't have done that. OptimizeRasters. Okay, I'll skip that. You can run Optimize. It basically creates a GP tool which you can run, and you basically point at the source data and point at where the data is to go, and it will actually convert the data, and it gives you a set of options of how you want to convert the data. It'll also copy all the metadata and other auxiliary files with the images across at the same time as actually doing the optimization. So it also includes tools for moving the data into the cloud. So if you're interested in actually working in cloud environments, the data process is very similar. You just point at data at the storage location in the cloud, and it'll actually convert the data and copy it into the cloud. And at the same time, it'll create what's called raster proxies. These are actually local files that are kept back on your machine, which you can then access and work with. But under the hood, they actually point to the data stored on the cloud, or potentially if you're using a slow NAS, you can also use that to speed it up. So once you have the data structured, what you need to do is to do the data management. We do that using Mosaic datasets. So Mosaic datasets are a way of managing the data. You create them and they reference the images, and then you can actually serve those through ArcGIS, the image server, and they become accessible to the various applications. Typically what you want to do is to split it into different modalities. So Mosaic datasets, you want to keep the natural color imagery separate from the multispectral imagery. And what you typically do is to create two types of Mosaic datasets, what we call source Mosaic datasets, which are used to handle the point where you have multiple rasters in a single project, and then create a derived Mosaic dataset which combines everything into a single Mosaic dataset that you can actually then use. There's not a lot of documentation about this in a stand. There's a URL which you can link to and find more information on it. So to create a Mosaic dataset, the simplest thing is to actually show an example. You can come back to the PowerPoint in a minute. So here I am actually in ArcGIS, and actually got some data. It's in a set of directories, and what I'm going to do is just go to my Mosaic into a file, in this case a file geodatabase, and say new, create a new Mosaic dataset. And what I'm actually going to create is a Mosaic dataset from a collection of Mr. SID files. So if we go just look in just File Explorer, if I go into Imagery, and you'll see that there are a whole load, about 200 Mr. SID files in this particular directory. So what I'm going to do is to create a Mosaic dataset off that. So basically say new Mosaic dataset. I'm just going to give this a name. So I'm going to go test for the time being. It's going to ask for the coordinate system. What I'm going to use in this case is I'm going to actually use the Mr. SID files actually don't have coordinates associated with them. So what I'm going to actually do is to import the coordinates from the actual files. So if I actually go to that directory, it was here is the actual projection of the data. I'm going to basically just use that as the projection to be used. So with that, I could just go run, and it's going to create my Mosaic dataset. This is actually going to be an empty Mosaic dataset. There's nothing actually in it at the moment. So that's basically created. And if I go back to my catalog, I can then go add rasters. And in the add rasters, what we can do is select where the data is. It's actually in a folder. So I'm going to basically say I want a folder, and I'm going to go to that folder which contained all those images, imagery, tiles, and go run. So what this is actually going to do, this is actually going to crawl through that directory and find all those images. It goes actually very quick. So it says there's about 230 images that it's found. It's going to go through those and extract those. Just very briefly, so what I do is you can use a file geodatabase or an enterprise geodatabase. You create your mosaic data set, basically use the source of the original data. We add the rasters, and then once the rasters are added, I don't know why it's taking time. Test. So those basically get added. Did it do it? So okay, so these are all now being added. If we actually zoom into the area, you can actually see the images. When you zoom out, the images don't appear because there are no what we call overviews in existence. And therefore, to create the overviews, all you do is you go back to this to the service and go build overviews. The trick in the build overviews is you have to define, well, not a trick, but in the build overviews. Sorry, what I meant is not build overviews, define overviews. First go define overviews. Typically what you want to do is to set the pixel size. I'm actually going to put it as 3.2 in this particular case. I'll explain how you get that number in a minute. So this is actually defining these overviews. This goes actually very, very quick. And what you see is this checker pattern. This basically means that the overviews don't exist yet. So that the high resolution data is there, but the overviews don't exist. So what we then do is to actually go back to the test and just go optimize and build overviews. This will now run. I know that it actually takes 2 minutes to actually run, and it's going to actually from the data set, the original data set was about, let's have a look. Optimized imagery properties. So it's about just under 3 gigabytes of Mr. SID files, and that'll take about 2 minutes to create the overviews. So once the overviews are created, what you do is you can define overviews, you set properties, and then you can actually do the quality assurance of the data. What you do in that case is you can actually edit the boundaries. So on the right-hand side, you'll see what I'm actually going to get is actually an image which actually contains black borders around the outsides. But what you can then do is to actually edit the footprints, edit the boundaries to remove the black areas, and then actually clip the footprints to the boundary, and then you get an image at the bottom. So what we're doing really is to create it's like a virtual mosaic of all the images. The additional data is actually very small. It's only the overviews, but we're not changing any of the source data, but we're creating this virtual mosaic of the data. So this is still running. I'll let this finish, and we'll carry on to the next part. So once you've created your source mosaic data sets, what you then want to do is to create your derived mosaic data sets. And this is a way of basically combining all the different images into a single mosaic data set. So again, you can either use a file geodatabase or enterprise. You create your mosaic data set, typically in this case using WebMaak. So although the images are in a lot of different projections, what I recommend in most organizations is to use WebMaak, unless in your organization you only use one projection for everything, you can use that. Otherwise, use Webmacator as a projection. The data will not be resampled or anything. It's just basically for the management of the data. So you create your mosaic data set, you add your rasters, and what you can do is you can just point to a folder which has actually the images in it and a directory, and it'll actually crawl through and bring all those in for the projects, the project rasters, where we have a single raster for a single site. You just point to the directory and it'll bring those in leaving all the data as it is. For the source mosaic data sets, what you actually do is you use the dataset capabilities within AdRasters, and that will actually bring in the mosaic data set as a virtual image. So there are a couple of other recommendations that we put here. One thing is you actually create a field called acquisition date. So mosaic data set is just really a database with lots of different fields. You can add acquisition date or any other metadata that you want, and you populate that with the names, populate that with the dates of all the different images. Typically those come from the, very often they're actually as part of the name. Otherwise, you just put them in. And there are a couple of other parameters that need to be basically set up. As I said, these are all recorded. You can go through this and make sure that these different parameters are set up. So you can, as I said, set the parameters, and then what you can do is to actually go and edit the footprints to remove things like no data areas. So if there are areas which have no data, you can actually just go to the editor capabilities and edit the footprint either manually or use the build footprints tool to edit the footprints. So here is that mosaic data set. You see that basically it's been created. I can now access it at any particular scale. There's the boundary here, and this boundary, you can actually then use the editing tools to actually edit the boundary and clip it. So you can clip it out, and the result of that will actually be a service like this one. And you'll see in this one, it's exactly the same service. I've only changed the boundary to remove it. So that's how you create the source mosaic data sets. So the creation of the derived mosaic data sets is very similar. Once you actually do that, you basically create a mosaic data set like this one. Let me just add this. So here is that. What I probably want to do is to change the projection. This is actually in a state plane projection at the moment, I think, in feet. So let me just change the projection of my my map into Webmacator. And so here we see this is what we call the derived mosaic data set. And if we actually open the attribute table for this, you'll see that it actually has properties, basically one record for every single image that's there, and this could be tens of thousands or literally millions of images long if necessary. So you have all the images in here, and this is your derived mosaic data set. And what you see here is there is an acquisition date that I've actually added to it. So if we zoom into some of these briefly, so let's go, for example, let's zoom to here. So here is basically one area, and you can see the overlapping images, and that the actual footprints have actually been clipped. The actual original imagery has like white borders on it, but the footprints have been edited to clip out those borders. So for the automation of this, there are a lot of different things that can be done automatically. I basically, in the documents, talked about how to do it manually. There are a lot of ways that these workflows can be made automatic, or rather automated. There's a lot of resources. If you go to this URL, you can find resources about managing imagery, either using, there's also a workflow specifically for pre-processed orthos you can have a look at. There's also from that site, you can actually go into a group in ArcGIS Online, and that you will see something called MDCS, Mosaic Dataset Configuration Scripts. These are a whole lot of scripts that can simplify and really automate the workflows. You really just create an XML file which defines the Mosaic datasets you want, and those scripts will actually go through the whole process of creating the Mosaic datasets for you. Very good method. If you get imagery regularly, you can just set up a script like that to run and keep adding the data. Also, there's OptimizeRasters that are referred to as also accessible from there. Once you have your Mosaic datasets, you can basically publish them as image services, either directly from Pro go to ArcGIS Enterprise, or from ArcMap directly to an image server. And these services, once you've published them, you can then register them either with Portal or register them with ArcGIS Online, or you can actually directly access them from your applications, and then incorporate them into web apps. So these web apps can then be very quickly put together. No coding is required in some cases. There is this image interpretation template. There's actually a beta version of it. The full version is coming out at the end of this year. I was going to quickly show how you can do that, but I might come back to this in a minute. Also, there is the Web App Builder. Web App Builder is a set of, something called WABIS for Web App Builder is a set of widgets that you can plug together and create these different applications. So have a look at both those. They can be used to create the applications. This image interpretation template was actually used to create the application that I showed you at the beginning. Quick things about elevation data. So I've talked mainly about ortho images. Working with elevation data is actually very, very similar. If the data is already gridded, you just basically leave it as it is, or run OptimizeRasters to convert it into a better format like LZW compressed TIFF or MRF. If the data is non-gridded, what I actually recommend you do is to actually create a gridded version of each of those different data sets. So if the data is, for example, LAS or point clouds, what you can do is optionally convert it to a format called ZLAS, which will significantly compress it and make it faster to access in desktop applications. Either way, you create what's called a LAS data set, which is really just a catalog of the LAS files, and then you can convert that very quickly to a raster. That's actually what I did for that point cloud data. Similar, if you have the data as CAD files, you can convert those CAD topper files into a geodatabase. Just use the CAD to geodatabase tool. You then create terrain, add the features to the terrain, build the terrain. Once the terrain is there, the terrain is really a sort of a triangulated mesh of the data. You can then convert it to a raster and create, and then convert the terrain to a raster, or actually add it to a Mosaic dataset and export it from the Mosaic dataset. But typically, what you want to do is to create a single raster for each image. Otherwise, the workflow is the same. You can basically, what you do need to take care of, mind you, is the vertical coordinate systems. It's very often necessary to convert, let's say, all the units that are feet into meters. Is typically what I do, so that the Mosaic data sets are all in units of meters vertically. Otherwise, obviously, you're going to have differences in change, which are significant differences in heights between the different data sets. And you can also add the raster functions, which are things like changing the symbology and stuff like that. So just in summary, basically review the data that you have and data structures and optimize if necessary. For collections of images that are part of the same project, create the source Mosaic data sets. Create these derived Mosaic data sets for each of those modalities. That's how you basically bring all these images together. You can serve those as image services, and then they become accessible either through desktop or web applications. Do make use of all the help information. There's a lot of help out there. If you don't want to do it yourself, or rather if you want help in it, consider there are jump starts from professional services. So Esri professional services actually provide jump starts where they'll come in for a few days and actually help you get all this set up and work you through it. The other thing to consider also is Esri also provide managed services engagements, and those are engagements which allow you basically where everything is handled by Esri. You just give them access to the data, and they will actually set up the servers and manage the data and serve it back to you. So those are also options if you depend if you want to go that way. So there's lots you can actually do. All the tools, you have them. If you have ArcGIS Desktop, you can start straight away, work through these tools, and set up the mosaic data sets, and then get them onto the server and start using them in the applications. Okay, I think we wanted just to go over to questions. Thank you.
Yeah. Well, thank you very much, Peter. A lot of valuable material there, and I'm sure it's going to drive some great conversations. So it's the time in the webinar that we answer questions. So let's see what you have submitted. Peter, I think you addressed this toward the end of your talk, but it relates to your first demo. Are these widgets standard in AGOL Portal 10.5.1? or just web app builder development?
So that's the application I actually demoed was actually built on what the image interpretation template, and that's actually there was a URL which actually had a link to that. That's not in Portal yet. The other way to do it is to use WABIS. So if you go to GitHub WABIS, these are actually widgets these are widgets that you can download and add to Web App Builder, and those work very well. They're actually the widgets that we use to create a lot of the imagery applications, and they're actually the source for some of the application templates as well, such as the image interpretation template. So have a look at that if you want. This is a very good resource for things like change detection, compare. All the tools that I was showing you are basically part of this widget as well.
Excellent, thank you. These next two questions have to do with updating some of the imagery. What is the best way to manage non-adjacent site imagery that needs to be updated monthly? And the second part of that question was, what is the best way to create a time series of images for quickly viewing year-to-year changes?
Okay, so with the workflows that what I forgot to actually mention is that when you create the derived mosaic datasets, you can just keep adding new images. So once you create your mosaic dataset, whenever you get new images, you just keep adding it to that mosaic dataset. You go through exactly the same workflow, and you republish that service. So from the user's perspective, nothing changes except they suddenly now get newer imagery. So that's the whole idea of the derived mosaic dataset. It contains the images from all these different places, but they're all attributed with time, and you can update them every time you get a new image. You just add it to the mosaic and to the derived mosaic dataset. So that's how that works. And then because you've actually had you add that attribute called acquisition date or year or whatever you want to put in there, you can then use that to drive various applications. So within ArcGIS Pro and ArcMap, when you add the image service, you can actually see those attributes and query and say, I'm only interested in imagery of a particular date, or you can actually get the system to order the imagery. I only want to see imagery closest to the year 2000, and it'll actually reorder the imagery based on various rules. So the key thing is to basically create the mosaic data set, serve that as an image service, include the attributes that you want, for example, acquisition date in it, and the system will handle it.
Great. Here's a question that just came in. Do you recommend file geodatabases for mosaic data sets versus SDE? Is there a difference there?
So typically in most cases I actually do a lot of my work using file geodatabase. As you get into the enterprise, it is good to use an enterprise geodatabase. So it depends really on the scale that you're getting to. If you're starting to work with large numbers of images, when I say large, tens of thousands, then I would start considering using a file geodatabase. There are some advantages, and I mentioned it briefly in the notes, especially if you're using this concept of having these source mosaic datasets which have a lot of images in it. And then you add that mosaic data set to another mosaic data set. What you're doing is actually cascading the databases. That's typically not a good idea in certain cases, especially when using a file geodatabase. So if you have a lot of, for example, Mr. Fitsid files that you're putting together and creating mosaic data, a source mosaic data set, and then adding that to the derived mosaic data set, that's where it's optimum to actually start thinking about having an enterprise geodatabase. If you do use an enterprise geodatabase, I would still not store the overviews in the enterprise geodatabase. What I would recommend you do is that you, when you build your overviews, that you actually always specify to store those on disk and not into the database. That ensures the database remains small. So you can both work. What also to realize is that since ArcGIS 10.5, we actually support Postgres differently, and a lot of users are moving to use Postgres now to store the mosaic data sets and to use it on an enterprise geodatabase.
Okay, great. Well, we're coming up to the top of the hour, so we should wrap things up. We've presented a lot of material today, so remember that this presentation has been recorded, so you'll be able to refer back to it when we're done here. I want to sincerely thank Peter and Chris and everyone who has attended today's webinar. There will be a short survey that will pop up right after the webinar ends, which we would greatly appreciate your feedback on. We use your suggestions and feedback when designing our future webinars, so your input is very important. We're looking forward to seeing you at our next webinar, which we will be scheduling and letting you know about shortly. And lastly, if you have follow-up questions, you're always welcome to contact me directly. It's Pete.Will at pwill@esri.com. Thanks, everybody.